Morning. Today we are going to talk about unit rate. This is our skill this week that we are going to cover to prepare for our mid-module check next week. So we're going to start on the first page of this lesson. We have a doghouse and we have two people here. He is saying, Mom, you are building the doghouse really quickly. At this rate, you will be done in no time. She says, I am so good I should charge a rate of $25 per hour to build doghouses. Rates are a part of everyday life. You may have used or heard the word rate quite often without noticing. As you can see, Randy and his mom are talking about rates when just working on their doghouse. But are they talking about the same type of rate? So the question is, what is a rate? Are there many other types of rates? Let's continue to follow the activities through Randy's weekend and explore the various rates he can encounter when learning more about them. As we head to page 2, we are reminded that a rate is a ratio where two measurements are related to each other. So we know what a ratio is. A ratio compares two things. A rate is when these two are related. So writing rates. While waiting for his mom to finish the doghouse, Randy decided to go for his daily run with his dog. Randy noticed he was able to run 3 miles in 30 minutes. Remember, a ratio is a comparison of two quantities. So for every 3 miles of running, 30 minutes have passed. Let's see this ratio written mathematically. So this ratio is written as a fraction here. It's written as 3 miles on top in the numerator and 30 minutes on bottom in the denominator. A ratio should be written as a fraction with one measurement in the numerator and the other measurement in the denominator, just like we see here. What makes this different? So notice how this is written as a fraction. The ratio describes Randy's running speed is called a rate. So a rate is a special type of ratio where two measurements are related to each other. So you can see the other different rates below here. These are all just examples. Being able to type, let's say 40 words in 2 minutes. It compares words in minutes. Being able to drive 200 miles on 18 gallons compares miles in gallons. This is a really common one. Being able to buy 18 ounces of cereal for $3.29. They're comparing your ounces in dollars. And being able to throw a football 70 feet in 4 seconds, you're comparing feet in seconds. So again, a rate compares two things that are related. So we can see example 1 here. During the last couple weeks, a runner kept track of her distance and times when she went for her runs. Her best distance and time is 4 miles in 36 minutes. What is the rate that compares minutes to miles? So she's running 4 miles in a total of 36 minutes. So you're comparing two things that are related, miles to minutes. As we see here, the rate would be 4 miles on top, 36 minutes on the bottom. This means that the runner runs 4 miles for every 36 minutes. You can also see example 2 here. The local market is selling 4 pounds of strawberries for $12. So our rate is $12 for 4 pounds of strawberries. As you move on to page 3, it talks about unit rate. So we just talked about what rates were. Now we're talking about a unit rate. So she says, wow, looks like you made $120 and you worked 8 hours. How much money does that turn out to be per hour, Mom? You need to figure out the hourly rate. That's equivalent to $120 for 8 hours. So unit rate, over here we are reminded a unit rate is a rate expressed such that it reveals how much of the first quantity there is just for 1 unit of another, such as 2 feet per second or $6 per hour. Randy, being a dog enthusiast, is raising money for a dog shelter by mowing lawns. He does not charge a specific price for every lawn. Instead, he just asks for donations. After spending the weekend mowing, he sits down with his mom. He gets curious about how quickly he made money. Look over the conversation that he has with his mom. So we did that up here on the top. All right, so a big rule that we need to remember here. Unit rates are easily calculated. Once a unit rate has been created, you will always divide both of the terms by the rate of the second term. So again, when you are making a unit rate, you are always dividing. Okay, not adding, not subtracting, not multiplying, but you're always dividing. So when we are finding out Randy's unit rate, remember he made $120 and he worked for 8 hours. So again, to find a unit rate, we always divide. So we have to do the division problem. We're going to divide them both by 8. Remember, fractions are division problems. So we take $120, we divide it by 8, and we discover that he makes $15 per hour. So Randy receives $15 per hour for mowing lawns. The second unit rate, another unit rate that can describe the situation, is created by reversing the order of the ratio terms. Instead of making $120 for 8 hours, you can say it took 8 hours to make $120. So he's worked for 8 hours, he made $120. He divides them both by 120. This is where we talked about a complex fraction when you say a fraction in the numerator. So you might first think that he should stop right here, and you can continue to simplify, or you could just scale it down. Because it takes 15/8 to add up to equal 120, 8 over 120 equals 1/15. So what this comes down to is that the unit rate reveals that it takes 1/15 of an hour to make $1. So they're not asking how much he's making for each dollar, but that would equal out to 1/15 of an hour to make $1. On page 4, you will see, we do see a caution sign here, so I always want to read those. Always be careful when determining both unit rates, because at times the second rate may not make sense in the real world. If a unit rate was $7 per book, does the second unit rate make sense? So like $7 per book does make sense, but a reciprocal of this would be that 1 cent of a book per dollar. That does not make sense, so we're not going to use that. You scroll down here, you have a couple examples. The first one, he talks about Randy needed gas for his lawnmower before he started cutting grass. To deliver 15 gallons of gasoline, it took the gas pump 3 minutes. Sometimes it helps to see a visual model of the rates. So here's a visual of this. So for 3 minutes straight, the gas pump is pumping out 5 gallons there, so you can see that. The rate is 15 gallons for every 3 minutes. You can see more visual here. And you can start to figure out that only one of the 5 gallons is labeled in that minute, so that means it's going to take 1/5 of the minute. I have some practice problems here. So practice problem number 1 says a babysitter has 32 pieces of candy for the 8 children that she must watch over. Calculate the unit rate of candy per child. So our unit rate is 32 candies divided by 8 children. We divide top and the bottom by 8 because we know that fractions are division problems. 4 candy per child. Practice problem 2. A bakery is having a sale and is selling 3 cakes for $12. It offered to sell pieces of cake as well. Calculate the unit rate for this scenario. So again, we're selling 3 cakes for $12. Our rate is $12 for 3 cakes. Our unit rate is where we divide both of these by 3 to figure out that each cake is $4. Now, they did talk about how you can buy slices of cake. So in that case, we would figure out that 1 cake is $4. If we divide them both by 4, we figure out that 1 slice is, or 1/4 of a cake can be purchased with $1. So as we get further into this lesson, you see unit pricing and unit sizes. As the weekend comes to an end, Randy received a great offer from one of his neighbors whose lawn he mowed. He would be given an extra donation if he could help his neighbor put fertilizer on some plants. Randy accepted. His neighbor shared a store ad with Randy. So here's the store ad. We can see that it looks like this fertilizer here is $9 for 6.75 pounds. This fertilizer is $18.50 for 14.8 pounds. His neighbor asked, which size should I purchase so that I pay less per pound? Randy knows all about determining rates, so this one is no different. Let's help solve this. You must determine the unit price, which is how much an item costs per unit. In this case, the units are pounds. So let's first write the unit or the rate as a fraction. which would be $9 for that first bag. And that first bag is 6.75 pounds. So the price in the numerator and the price per pound, they'll have the pounds on the bottom. So we calculate the unit rate, put $9 on top, 6.75 on the bottom. We divide them both by 6.75. Remember, we always divide when we're finding unit rate. And you discover that it is $1.33 a pound for that first bag of fertilizer. You could also discover that 6.75 pounds divided by $9 is a total of 75 cents per pound, or 75.75 pounds for every dollar spent. Randy's neighbor wants to pay less per pound. Option 1 is $1.33 and option 2 is $1.25. Clearly option 2 is the better rate. So after we discover the unit rates of both of those bags of fertilizer, you discover that the option 2 is the better choice. As you scroll down, you can see the unit rates. They're very helpful in situations like this. This is a really good real-world problem. When you go to buy mulch and fertilizer, you always want to get the most for your money. So in this example, they are explaining that. And as we go on to page 6, you have some practice here.